Now, we're going to look at logarithmic equations, 7.4, and there's two types of equations that you're going to run into. And one of them is similar to kind of what we were looking at yesterday, and one of them is very different. Okay, so you have to be able to keep them straight because you do something a little bit different depending on which type of situation you have. For 7.4, you'll have two different potential types of situations, and you have to apply the right principles to the right types of problems. Okay, and you just got to keep that straight. Okay. The first one is like this. So it looks like logarithmic form of an equation. That's it. There's one log in the problem. Okay, and so when you have a problem like this, when there's only one log, all you do is rewrite it into exponential form and simplify it. Okay, so that's the part that's like what we did yesterday. Okay, so when there's only one log, rewrite it in exponential form and simplify. So go ahead and do that right now, please. So what is the exponential form of this?
3 over 2 equals x.
Okay, correct. So at my first move, whenever there's only one log, is to write it in exponential form. Now, in this particular problem, it's just a matter of simplifying this to find out what x is. Okay? The x doesn't have to be here. The x could be here. The x could also be here. All right? And if the x is here, then what you're going to have is something to the x power. So we'll have an exponential equation like we did in 7.2. And you may need to change the base and get the powers equal to each other, that kind of thing, just like we did in 7.2. So that happens when the variable is over here. Okay? But here, this one's pretty straightforward, right? What does 9 to the 3/2 really mean? Square root of 9 to the 3rd. Okay? Square root of 9 to the 3rd, or you can put the 3 on the inside too. The reason I chose to put the 3 on the outside is because I can find the square root of 9 pretty easily, right? Makes the number smaller right away. If you have to do 9 to the 3rd, you can, and you can knock that all out on your calculator. That's just fine. For that matter, you can type 9 to the 3/2 in your calculator. But my preference is always to minimize my work that I have to do on a calculator. Square root of 9 is what? 3 to the 3rd is 27. Okay, so x equals 27. Now, here's the key. I want to, before I move on to the next problem and make sure that that's right, I want to make sure both of these numbers are positive. Because if they aren't, then we have a problem. And so obviously 27 is positive, 9 is already positive, so we're in good shape. Right? So that's the first type of problem you're going to be doing for homework. When there's one logarithm, you're going to switch it into exponential form and simplify until you find your answer.
Well, how many times there's negative?
Okay, so if this was the only solution we came up with and one of these two was negative, then you'd say there was no solution. For one log situations, that's really not going to happen. Okay?
So that's all we're doing today?
No, that's half of what we're doing today. So that's the one type of problem that we're doing today, when there's one logarithm. The other type of problem we're going to do is when there's a log on both sides. Okay? And when there's a log on both sides, they can become a little more complex. And the steps that we take are different. Right? And the steps that we take are more like what we did in 7.2. The first thing we have to look out for is we need to make sure that the log base is the same on both sides. Okay? Because really what that means is if the log base is the same on both sides and the left-hand side equals the right-hand side, then what has to be true is that this has to equal that. Okay? And so essentially what we're going to do is set what I've circled in blue equal to each other, solve that, and I'll find out what x is. The one thing that I want to caution you on problems like this, you do have to check your work. Because sometimes you'll get solutions that actually won't work, and it goes back to the idea of making sure that both of these numbers are positive. Sometimes it can turn these into negatives, and if that's the case, we have to throw that one out. Okay? So those are the two different types of problems. One log, change it to exponential form. two logs, you're just setting them equal to each other, and then you're going to solve. Okay. So in reality, what I have here is I'm setting x squared minus 15 equal to 2x, and now I have to solve that, which we know how to do. What type of equation is this? It's a quadratic, right? Okay, so what do I have to do to solve a quadratic? What's my first move? Set it equal to 0, correct. So I got to set one side equal to 0, and then I have to solve by factoring, quadratic formula, or however you want to. So go ahead and finish that one. So my first move is to move the 2x to the other side. Okay, so I'll get x squared minus 2x minus 15. That's factorable because factors of negative 15 that add up to negative 2, negative 5, and 3. So I can factor that and solve it. Okay, so x equals 5 and x equals negative 3. Even if you use quadratic formula, that's what you should have got. How many have those two solutions? Okay, so here's the next piece. We have to check both of them to make sure that neither one of these things end up being negative. Okay, so let's start. Go ahead and check 5. All right, and that's all we're checking for. We're checking 1 to make sure when you plug it in you get the same thing on both sides, but 2 that neither one of these are negative. So go ahead and check 5, and then just stop. Don't check negative 3 yet. Just check 5. And so just like when we've done our other checks, you have to plug it into the original equations. Do not plug it in to the quadratic. Plug it into the original equation. So there's the check for 5. Okay. So again, I plug it back into the original equation. 5 squared is 25 minus 15 is 10. 2 times 5 is 10. Neither of these is negative, so 5 is fine. Okay. Now go ahead and plug in negative 3 and check that one. So here's the check for negative 3. Okay. And so this is the issue, right? It equals the same on both sides. However, as we've stated yesterday, this number can't be negative. And the reason why it can't be negative is because let's understand what a logarithm is again. A log is a power. Okay? There's no way to take 3 to some power and then it will equal negative 6. That's why that number can't be negative. There is no number that you can substitute here that will make this true. And this is the reason why this can't be negative, which means we have to throw this solution out. So we have to throw out negative 3 because it turns what's next to the log, what's inside the parentheses, it turns that into something negative, which is bad. We can't have that. That's sort of one of the foundational rules of logarithms. So in reality, what I have is one solution, x equals 5, that's it. And that's why you have to check, because this can happen, and yes, you have to show it. All right? So just to tie it up, tie a bow on it. There's two things in this section. One is if there's one log in the problem, you're changing it to exponential form. If there is a log on both sides, your goal is to make sure that the log bases are the same on both sides, and then you're just setting the numbers equal to each other and solving and checking. Okay?
What do you do if the log bases aren't the same?
That won't happen in this section. When we get to that, I mean, we will do that, but that will come in the sort of next unit, 7.5 to 7.8, and we'll talk about how to deal with that. Question? Yeah?
What made you compare 3 to negative 6?
Oh, this down here? Because in reality, a logarithm is a power, so this really means 3 to some power equals negative 6. And so I was just illustrating that there's no way to raise 3 to any power and make it turn into negative 6.
The power can't be 3 to 10.
I'm confused on what cannot be.
3 to
For when you input is 5,